Hello, welcome back. Today we're going to be finding the areas and perimeters of similar figures. The objective is that by the end of this video, you should be able to find the missing side length or area of two similar figures. To get us started, we've got some vocabulary to look at, the first of which is similar figures. And similar figures are figures that have the same shape but different size. For example, these two figures are similar because they're the same shape but different size. Now this isn't so important for this particular video, but also remember that they have to have all of the same angles, which leads us to corresponding sides of similar figures. They're sides that are in the same position of two similar figures. Side AB, that would be from here to here, of the red triangle corresponds to side what of the blue triangle? Well, A to B goes along this side, which corresponds to JK of the blue triangle. So this leads us to our first example, which is going to be to write the ratio of the side lengths, the ratio of the perimeters, and the ratio of the areas of the blue rectangle to the red rectangle. So we're going to be comparing from this blue rectangle to this red rectangle. Now that means the order we compare them in has to be blue first, red second. And again, we can always make these comparisons using either the semicolon or a fraction. I'm going to choose the semicolon because that's how your book is going to choose to do it. To find the ratio of the side lengths, we just need to find two corresponding sides. Again, we're going to be going from blue to red because they told us we're going to compare blue to red. So we have a side length of 8, and we're going to compare that with the semicolon or fraction to the 12. Now, when you're writing ratios, you always write them in reduced form. So we can divide both of those by 4, giving us 2 to 3. That should be the ratio of the side lengths. That means anytime we have two corresponding side lengths, they'll have a ratio of 2 to 3 when we reduce our fractions. Now the ratio of the perimeters, here's good news. It's always the same as the ratio of the side lengths. So it's going to be 2 to 3. That's because if you add up all the sides and then divide the corresponding sides, it's still going to be the same ratio. But what about the ratio of the areas? Well, area means you take the side lengths and you start multiplying them. Like if this was 5, it would be 8 times 5. So the area would be 40. If this one would be some other length, you'd be multiplying them. Well, the ratio of the areas, since multiplication is involved in finding area, ratio of the areas won't be just the same as the side lengths. As a matter of fact, it'll be the square of the side length. So it's going to be 2 squared to 3 squared. Now we don't want to write it like this. We can write it a little bit simpler. We're actually going to square those numbers. 2 squared is 4 to 3 squared is 9. So again, the ratio of the areas is just the square of the ratio of the side lengths. So what we're going to be asked to do with this information is to find an unknown area of two similar figures. The way we're going to do this is first we're going to find the ratio of their areas. Then we're going to make a proportion to solve for the missing area. Now, to find a ratio of their areas, remember we take the side lengths and we square both of them. So the ratio of these two figures' areas is going to be 8 squared. I'm going to go small to big over 15 squared. Now, I'm choosing to use a fraction this time instead of a colon because in a moment we're going to write a proportion, and proportions usually indicate we're going to have fractions. So 8 squared over 15 squared is going to be 64 over 225. This is the area of the small rectangle compared as a ratio to the area of the large rectangle. So we get 64 over 225 equals the area of the small over the area of the larger rectangle. So we get the small area, question mark, over the larger area, 50. And we don't have to square these because they're already giving us the areas, not the side length. So how we're going to solve this now is we're going to cross multiply, and we get 64 times 50 divided by 225. So let me show you that in the calculator. 64 times 50 divided by 225. And you get 14.22 should be the area of our smaller rectangle. Since I didn't give you the unit, I'm just going to write units squared. So it's 14.22 units squared. So here's a problem for you to try on your own. I ask that you go ahead and pause the video, work this problem out, and then press play when you're ready to see the answer. Alright, for this one actually asks us to find some other information. We had to find the ratio of the perimeters first, and that's pretty easy. Let's see, they say shaded to unshaded. That means that the shaded has to come first, the unshaded has to come second. So the shaded is 12, that's our side length. 2, or we can do a division, doesn't really matter, over 21. Now we don't want that to be an unreduced fraction, so we need to go ahead and reduce it. Both those are divisible by 3, giving us 4 over 7. That's the ratio of the perimeters of these two figures, or the ratio of the side lengths. Now the ratio of the areas is going to be 4 squared over 7 squared, which is going to be 16 over 49. Now that's the ratio of the areas. The last thing it asks us to do is to find the unknown area. So we're going to be looking for this area right here. Now to do that, we have to set up our proportion. The ratio of the areas, 16 over 49, is equal to the ratio of the areas that we are or are not given. So we still have to go from the shaded to the unshaded. This area is a question mark, we don't know it. Over this area is 441. So what we're going to do is we're going to go 16 times 441 and then divide by 49. So we get 16 times 441 divided by 49. And we get our missing area to be 144, in this case inches squared. So our missing area is 144 inches squared. And that's the answer for the missing area right here. Now we can also go backwards when we're writing our ratios. Now if we look at this problem right here, we notice it asks us to find the ratio of the lengths of the corresponding sides. And we're given the ratio of the areas. Well, if you're given the ratio of the areas and you're trying to go backwards to the ratio of the side lengths, you're going to undo what you would have done to get from the lengths to the areas. In other words, instead of squaring these, since they give us the areas, we're going to take the square root of them. So it's going to be the square root of 256 to the square root of 169. So you can take your calculators and you can go second x squared 256 and second x squared 169. And you should be able to get your fraction of 16 to 13 is the ratio of the side lengths. And again, what we were given the ratio of the areas, and we had to go to the side lengths, so we took the square root instead of squaring them. So suppose we're given a couple of figures that are similar, ABC is similar to JKL, and we're given a couple areas, and we're given a side length. And somehow we have to magically find a missing side length. Well, the good news is we can still use a proportion to solve this, but since we're asked for a missing side, we need a proportion with just the sides. Now, we're given the areas, so we can make a ratio of our areas, 56 over 22, and we can turn that into a ratio of sides. By the way, this is the ratio of the areas. And we can turn that into the ratio of the sides by taking the square root of both of them. So square root of 56 and square root of 22. Take our calculator. Square root of 56 and the square root of 22. And we'll get a couple different numbers right there. We'll get 7.483. and 4.69. Now that's the ratio of the side lengths. We can make that equal to, in this case I went from the larger triangle to the smaller one. So the larger triangle is 9. Over the smaller triangle length we don't know. So again, all I did was I found the ratio of the side lengths by taking the square root of the ratio of the areas and then made it equal to the side length I know over the side length I don't know, going from large to small. I can cross multiply. This time I'm going to go 9 times 4.69 and then divide by 7.48. And I find my missing side length in the end is 8.83, and I didn't give any units, so we're just going to say 8.83.